Have you ever just looked up at the night sky and dreamed of actually going to another star? I mean, it sounds like something straight out of science fiction, right? But what if I told you there's a real way to travel across the vastness of space using, well, nothing but sunlight? Okay, let's get into this because what NASA is doing with its next-gen solar sails is turning this wild dream into a very real possibility. So, right off the bat, here's the huge problem we're up against. The universe is just mind-bogglingly big. Trying to get to even the closest star to us is a challenge that makes everything humanity's ever done before look tiny. So, how do you even begin to solve a puzzle that massive? The rockets that took us to the moon were incredibly powerful, but they're sprinters, not marathon runners. They burn through all their fuel in a matter of minutes. For a trip between stars, that kind of chemical propulsion just isn't going to cut it. We would literally be looking at a trip that lasts longer than all of recorded human history. So the bottom line is, we need a totally different approach. We need a new kind of engine. And that new engine, it might just be one of the most elegant and, honestly, poetic ideas in all of space travel. A sail. But instead of catching wind to cross an ocean, we're going to catch light itself to cross the cosmos. Now, the secret sauce to all of this is the photon. Just a quick reminder, photons are these tiny little particles of light that are constantly streaming out from the sun. And here's the weird part. While they don't have any mass, they do have momentum. Think of it like a ghost trying to play pool. You can't weigh the cue ball, but when it hits another ball, it still gives it a tiny little push. And the idea itself is just beautifully simple. A single photon's push is almost nothing, but the sun is pumping out trillions upon trillions of them every single second. So as they bounce off a giant, shiny sail, each one adds its tiny bit of momentum. It's not some violent explosion like a rocket launch. It's this gentle but constant acceleration. It's like a marathon runner. Every step is small, but over time, all those steps add up to incredible speeds and unbelievable distances, all without using a single drop of fuel. And listen, this isn't just some theory on a chalkboard. This technology has been evolving for decades. And what NASA is working on now, these next-generation designs, are really pushing the limits by making these sails bigger, better, and way, way faster. The jump we're talking about here is just enormous. The first sails were kind of small, just test projects, really. But the new concepts are massive. We're talking hundreds of square meters, some as big as a football field. And they're made from materials that are 40 to 100 times thinner than a single sheet of paper. See, being bigger means you catch more photons, and being lighter means every one of those little pushes has a much bigger effect. It's basically like upgrading from a little rowboat to a massive, high-tech racing yacht. So engineers are looking at a few different ways to build these things, and each design has its own unique advantages. You've got the square sail, which is kind of a classic, stable, kite-like design, great for missions where you want something that's been proven. Then there's the heliogyro, which is a bit more radical. It's got these long spinning vanes that make it super efficient and lightweight. And then you have the spinning disc, which uses its own rotation to keep the sail tight, which means it could unfold all on its own without a bunch of complicated machines. Really, the best design just depends on what the mission is. Okay, so we've got the physics down and we've got the engineering concepts, but has any of this stuff actually worked, out there in the cold, hard vacuum of space? And the answer to that is a big yes. This tech has a real track record. This whole journey actually started way back in 1960. NASA's Echo 1 satellite, which was basically just a big balloon, was literally getting pushed around in its orbit by sunlight. That was the first proof. Sure, there were setbacks, like when the Cosmos 1 mission failed to launch in 2005, but then, in 2010, everything changed. Japan's Icaro spacecraft successfully flew right past Venus using nothing but a solar sail. It proved, once and for all, that we can sail the solar system. So with the concept now proven, and the technology getting better and better, we can finally start to talk seriously about the ultimate goal, using these sails to leave our solar system completely and travel to another star. And this is where things get really, really ambitious. There's a project called Starshot that has this radical new idea. Instead of just relying on the sunlight that happens to hit the sail, what if we built a massive array of lasers on the ground and fired it at a tiny spacecraft with an ultralight sail? This super-focused beam of light would act like a massive cannon, pushing these little nanocrafts to unbelievable speeds. So remember that tens of thousands of years trip with a normal rocket? With the Starshot idea, a mission could get to Proxima Centauri, our closest stellar neighbor, in just over 20 years. 20! That's a journey that could happen within a single human lifetime.
It completely rewrites the rules for interstellar exploration.
But of course, we're not packing our bags just yet. There are some huge engineering hurdles to clear. I mean, how do you steer a tiny craft that's moving at 20% of the speed of light? What kind of material can even handle the incredible force of that laser beam without just disintegrating? And maybe the biggest question of all, once it gets there, how does a probe the size of a postage stamp send any data, like pictures, all the way back to us across 4.2 light years of empty space? These are the tough questions scientists are tackling right now.
But these are exactly the kinds of challenges that push humanity forward. As Robert Goddard, the father of modern rocketry, said, the dream of yesterday is the hope of today and the reality of tomorrow. Sailing to the stars on a beam of light, it isn't just a dream anymore, it's today's hope. And with every new mission, every new breakthrough, we're getting one step closer to making it our reality.